Thousands of soldiers in World War II did not fall to bullets or artillery. They were neutralized by something far more fundamental: the biological limits of the human body. In the history of total war, victory often depended on a simple interface, where the soldier's foot met the inside of his boot. The war in Europe was a struggle against geography and climate. It was fought in freezing rain, deep slush, and miles of exhausting marches. For an infantryman, movement was not just a tactic, it was survival. As long as a soldier could keep moving, he remained an effective unit. The moment his mobility failed, he became a strategic liability. This was the silent tragedy of the front lines, the physical breakdown of the man before the breakdown of the machine.
In the mud of the Eastern Front, the environment was the primary enemy. Constant moisture and cold created a cycle of extreme stress on human tissue. This led to a condition known as trench foot, a non-freezing cold injury that could incapacitate thousands. When leather boots soaked through and stayed wet for days, the skin softened and the blood circulation began to fail. In these conditions, even a small blister could become a path to severe infection, turning a seasoned veteran into a casualty without a single shot being fired.
Movement depended on a simple system: the military boot. But in Eastern Europe, the cycle was brutal. Rain turned roads into sticky traps, and snow melted only to freeze again at night. Water seeped into the boots and remained trapped there. The leather became a cold, heavy cage that accelerated the loss of body heat. Thousands of men were removed from the battlefield, not by iron, but by the failure of their footwear to protect the integrity of the human foot.
A marching army is a logistical engine, but that engine stops when its parts fail. When the boots failed, the feet followed. When the feet failed, the offensive died. This wasn't just a matter of comfort, it was a matter of national survival. The USA, Germany, and the USSR each approached this problem differently, and the price for their engineering choices was written in the ice of the front lines. The American approach to military footwear was a reflection of industrial power, yet it faced the same biological reality as any other army. U.S. combat boots were manufactured from high-quality leather and equipped with durable rubber soles. On paper, they were designed to provide superior support and reduce physical exhaustion during long movements. In stable, dry conditions, these boots performed exceptionally well, allowing soldiers to maintain a high pace of movement across varying terrains. However, the battlefield is rarely stable. The fundamental engineering flaw of leather is its capacity to absorb moisture. In the constant rain and melting snow of the European theater, even the best American boots eventually became saturated. This wasn't just a matter of discomfort, it was a matter of physics and biology. A wet leather boot can double in weight, significantly increasing the metabolic cost of every step. This leads to rapid muscle fatigue, which in turn degrades the soldier's focus and combat effectiveness.
When moisture stays trapped against the skin for extended periods, the tissue begins to soften. Friction from constant marching then creates blisters, small injuries that, in a tactical environment, serve as entry points for infection. The American soldier faced a constant struggle. His equipment was high quality, but it could not overcome the basic biological fact that wet skin is vulnerable skin.
The American solution to this problem was not a change in biology, but a triumph of logistics. Instead of trying to create a waterproof miracle, the U.S. system focused on the rapid replacement of exhausted gear. If a boot became a liability, the industrial machine provided another. Factories produced millions of pairs, and a massive supply chain moved them across oceans to the front lines. The strategy was to outpace the rate of physical degradation. The American advantage was not just the boot itself, but the invisible system behind it that ensured a soldier's mobility was restored before his feet reached the point of total failure. In the war of attrition, this ability to absorb and replace loss was a critical factor in maintaining the momentum of the offensive.
The German military tradition produced the jackboot, a symbol of discipline and engineering precision. Yet, on the Eastern Front, this rigid design encountered a biological limit it was never intended to cross.
The tall leather construction provided ankle support and protection, but it simultaneously created a lethal thermal environment. During intense movement, the human foot generates significant heat and moisture. In a sealed leather chamber, this perspiration has nowhere to evaporate. When the movement stops, the trapped moisture cools rapidly, and in sub-zero temperatures, the boot effectively becomes a vessel of ice.
Thousands of German casualties were the direct result of frostbite, not because of a lack of footwear, but because the footwear failed to manage the thermodynamics of the human body in a static, frozen environment. As high-quality leather became a luxury and supply lines grew longer, the German army remained trapped in an engineering philosophy that the climate had already rendered obsolete.
In contrast, the Soviet Union abandoned the pursuit of traditional perfection in favor of raw practicality. Facing a shortage of natural leather and a desperate need to equip millions of soldiers, Soviet engineers turned to Kirza, a multi-layered synthetic fabric impregnated with protective coatings. From a design standpoint, Kirza was primitive. It lacked the aesthetic appeal and the ergonomic fit of Western leather boots. However, in the context of total war, it served a vital physiological purpose. It provided a consistent barrier against external moisture. Unlike lower-grade leather, which absorbs water and loses its structural integrity, Kirza remained functional in the deep mud and slush of the Russian landscape. The Soviet system did not aim to provide comfort. It aimed to provide a sufficient shield. By simplifying the manufacturing process, the logistics machine ensured that no soldier was left barefoot. This availability was a strategic masterstroke. While the German soldiers struggled with a failing ideal, the Soviet soldier marched in a functional reality. In the final analysis, the question of which boot was superior is secondary to a much larger question. Which logistical system could sustain a soldier's ability to move under the pressure of total war? The battlefield is the ultimate testing ground for engineering logic, and war does not reward comfort or tradition alone. It rewards the capacity to endure.
The American logistics engine succeeded because it was designed to absorb failure. It did not matter that leather boots eventually soaked through or wore out in the harsh conditions of the European theater. The U.S. system treated footwear as a consumable resource, much like ammunition or fuel. By maintaining a constant, overwhelming flow of replacements across the Atlantic, the American machine ensured that localized gear failure never turned into strategic paralysis. Mobility was preserved not by creating a perfect waterproof boot, but by ensuring that a new pair was always waiting before the old one reached the point of total collapse.
The Soviet Union operated on a different but equally effective logic of mass pragmatism. By prioritizing Kirza, a material born of necessity and industrial scale, they removed the dangerous dependency on scarce natural resources. The Kirza boot was not a masterpiece of ergonomics, but it was a masterpiece of availability. In a conflict involving millions of men, providing a functional, moisture-resistant shield for every foot is a decisive advantage. The Soviet system thrived because it accepted sufficient as a standard for victory. It ensured that the momentum of the Red Army was never halted by a shortage of basic equipment.
Germany, meanwhile, fell victim to the rigidity of its own standards. As the war of attrition deepened, the complexity of their production and their reliance on high-grade materials became a terminal liability.
In the end, the outcome of the war was decided not just by the caliber of guns or the thickness of tank armor, but by the relentless logic of the systems that kept the soldiers moving. Movement is the fundamental law of survival on the front lines. An army that can take the next step remains a threat. An army that stops becomes a memory. Victory did not belong to the most sophisticated design. It belonged to the system that continued to function when everything else began to fall apart.